Hello everyone and welcome to this Java hands-on session. Today we will get in touch with Java modular programming using Maven. So before starting our demo, let me explain a few things about modular programming. So nowadays it plays an important role in software development and offers many advantages. For example, separation of concerns, which means dividing system into distinct non-overlapping modules or components, each addressing specific aspects or responsibility, so to reduce project complexity and enhance maintainability. And the second benefit is encapsulation. To achieve loosely coupling of the modules, the involved modules have to be connected to each other through well-defined APIs. This can be achieved if you have strong encapsulation, so a module doesn't depend on internal implementation of other modules. So let's have a look at this example. This is a monolith project. It is a fuzzy search tool, and as you see, the algorithm, the analysis, and the reports are implemented in one project. So before Java 9, it was also possible to break down the project into sub-projects. Maven made it even easier, so it was possible to define many sub-projects. However, this approach had a drawback because before Java 9, for example, if analysis has access to this module, so all public classes are exposed. We didn't have a way to control which classes are exposed to other modules. The only way was to put all classes in one package, and only the API is defined with the public accessor. But this is not convenient. Fortunately, starting from Java 9, a new layer is added to the old mechanism. So all we need to do is to define module descriptor for each module. And here you can define packages are exposed using the keyword export. And here you need to define which dependency you need for in this module. And this is big enhancement. So the dependency is not only defined at runtime, but also at compile time. So now let's start with a concrete example. For our demo, we will create a Java project using this Maven command. It just creates project according to this archetype, quick start. So let's run the command. Now let's open the project in IntelliJ. So this is our project. First, let's check that it is working. We have this class. So we need to adjust the Java version. The compiler is 18. Let's reload. And as you see now, it is working. We will not put all our implementation in this project. We will break it down into sub-module. And for that, we need to adjust our POM file, change it to the packaging to POM. So, and inside the project, we will define two new ones. The first one, let's go inside. So we added the first module that will contain the implementation of our distance for our measures. After that, we will create a module for the analysis. In the IDE, we see that the two module has been added. So let's install the project. Yes. And we reload. And as you see, the projects are recognized as valid Maven sub module. And we see inside our parent POM file, we see that the module are referred here. Also, Maven automatically define this project as parent. So in this module, we will add an API for our algorithm, an interface API, let's call it measure. It has two methods and one for the distance. And we add an implementation for that. So other modules should normally access only this API. Let's add an implementation. For example, this one, Levenstein, it implements our interface. We have to provide an implementation. Levenstein, and we provide a dummy implementation. It returns this one. And now let's consume this class in the analysis module. We go here. What we need to do is to, and IntelliJ suggests to add the dependency, the Maven, to the POM file for that. And now we can import the class and we can consume this we provide the distance name, and we calculate the distance between these two words, Stephen, string format, and let's see. So this is the old way to achieve modular programming without using the new feature added in Java 9. So everything is working, but we have a problem. So this internal implementation is not supposed to be accessed from outside this module. Unfortunately, there is no way to achieve this encapsulation. The only way is to define this class inside this package and make it package default. To use the new feature, so all we need to do is to add a module descriptor for both modules. First one, so the descriptor should be under this folder Java. If you click here, you get suggested by IntelliJ. So if you click here, for example, you don't get this suggested. You see it is insensitive. So now we have this one here. We do the same for this project. Let's go here, new info. And now let's try to run. And as you see, IntelliJ recognized that we are now using modular programming, so we cannot directly access public class from other modules unless we export them explicitly. And you get that this suggested here, add export, and the same for that, add export. And now, and not only that, after exporting, so if you check here, both classes are exported. Only what you export here can be consumed from outside. So this is not enough, because you need to require, you need to explicitly say, okay, I want to use exported things from this module. Now let's run, and you see it is working again. However, this has a drawback, because this implementation is an internal detail and it shouldn't be exposed or used outside. And to solve this issue, we need to remove the implementation from here. If we do that, you see that now we get an error. So the solution is to inject this implementation inside this one, and Java has an internal mechanism to achieve that using service loader. So this one, we need to define a service here. So how we can do that? Using this one, provide. So you define a service, so you provide this one with an implementation. So you need to provide an implementation for that. Let's say impl Levenstein. This is not enough. You have also to use this service here by specifying API measure. Now we can remove this one. We cannot directly use this implementation. Instead of that, we will use the service loader provided by the JDK. So it is an internal mechanism, load, and you specify which class. After that, the loader provide an iterator. So this is our iterator, and we will use a loop for that. As next, we can equal next. This would be, and we put this line here. So now we are not accessing the internal implementation. We are using this service loader, so the implementation is injected. Let's check whether this is working, and as you see, it works. So this was a demo how to use modular programming using Maven. I hope you find this helpful. Thanks for watching, and bye.